Okay, I'm going to get us started here on how to read this chart, which at first glance might look a little intimidating or crazy, but it's actually not too bad. To help you, you might want to have a little piece of paper with a straight edge on it. We've kind of done stuff like that in the past with these, so that would be, for me, I've got this little thing here that moves around for us, and I'll be able to use that as my straight edge. And so you can kind of use your own piece of paper like that on your an actual printout, which is more useful. Okay, so let's take a quick zoom first and see what's actually on the axis. First, over on the left, you'll see travel times, and I want you to take a look at what we're dealing with in terms of numbers here. So this means how long it takes for the earthquake waves to go various distances. And I want to show you, if you look like say between 11 and 12 minutes right there, if I zoom in a little tighter, you should see these little boxes basically, and we have to understand what those mean. So basically, if you take a whole minute and you divide it into thirds, that's 20 seconds a piece. So it would be, if you were on this little line right here, you'd be 11 minutes and 20 seconds. This would be 11 minutes and 40 seconds. This would be 11 minutes and 60 seconds, which is otherwise known as 12 minutes. So that's pretty important to know how to read what that is. Now, you're never guaranteed to land right on an exact line or box, because if you look maybe over here at a point like that on the right here, that's like 11 minutes and a little more than 20 seconds, but it's about halfway between 11 and 12 minutes. So I would call that 11 minutes and 30 seconds. So this is just kind of general thinking about what this thing actually shows us. Okay, so let's zoom back out a little bit here, and I'm going to show you the lower axis down here. And these are distances. And so I want you can even write this on there if you want. This 1 and this 2 and so on, we're multiplying that by 10 to the 3 kilometers. So let's be real here. That means this is 1,000. So this right here would be 1,000. This would be 2,000, 3,000, and so on. So just understand, they're trying to keep it not so busy. So they do some abbreviating here and just do 1, 2, 3, 4, 5, 6, 7, but they really mean 1,000. And it's in kilometers too, not miles. So there's another surprise. So let's talk about what these boxes mean. And I'll zoom in a little tighter between 1 and 2,000. So you've got all these little boxes. Well, what do they mean? Well, we're dividing it, a whole 1,000, we're dividing it into 1, 2, 3, 4, 5 chunks. So, well, what does that mean? That means that each one of those is about 200 kilometers. So watch as we go here. This is like 1,200, 1,400, 1,600, 1,800, and then 2,000. So that's how you read that. And again, similar to with time, you're not always guaranteed to fall right on one of those. So if you pick a curve up here, which we're going to do in a minute, if we were looking at that spot right there, well, if you come down, you have to estimate. So watch what happens. So that would mean if I went down from that dot to the axis, it's 1,200, 1,400, 1,600, and then there's 1,800. Well, it's about halfway between 16 and 1,800, which is 1,700. So estimating is okay. And again, perfection is not always going to happen there, but that's all right. So just remember those are thousands, and each box goes by 200 kilometers. So I'm going to move this piece of paper out of the way really quick here. Let's see if I can get that and move it. There we go. I just want to talk about what these curves mean now. And we talked about in the other video P and S waves and what they were. This just shows you how fast they are and how far they get in different amounts of time. So if you kind of pick, let's do a random spot here in time, let's say in 10 minutes. 10 minutes is a nice round number. In 10 minutes, how far does a P wave go? And so you go all the way across and you stop and when you hit that curve. And the same for the S wave curve. So you've got two different points here. I'm going to look at them individually. But let's do the 10 minutes. And I'm going to zoom in just a little bit. 10 minutes. And we're going to see how long it takes or how far a P wave goes in 10 minutes. And so you go from that dot where I hit that P curve, you come down and somewhere right there. So again, I'm saying in 10 minutes, a P wave can go 6,000, but 6,200, 6,400, probably about 6,500. So, around 6,500 kilometers in 10 minutes. Now, the S wave, well, that's somewhere right about here. So if you went down and read that, again, using a straight edge is much preferred to me winging it with my freehand, but I kind of can see the line up there. This is about 2,900 kilometers. So what did we say as far as time or how fast these things are? We said that P waves were faster than S waves. And so in the same amount of time, in 10 minutes, we said that this P wave can almost go 6,500 kilometers, where the S wave is only going to get about 2,900 kilometers. So the P waves are always outrunning the S waves is what we're saying. And so, if you go out, if I kind of reverse this and get rid of all this red stuff, and we look at, all right, let's pick a random place. If I am 4,000 kilometers away from an earthquake, we can actually read this in reverse. I'm going to get, if I'm 4,000 kilometers away from wherever that earthquake happens, so that's actually kind of close to like somewhere in Texas and an earthquake that happens in California. Well, it's going to take about, let's find out. It's going to take about 7 minutes or so for the P wave to actually get here to Texas from where that earthquake is, which, by the way, is fast. That is super fast, just saying. The S wave, though, if I'm 4,000 kilometers away, you have to keep on going up until you find the S wave curve. That happens right there. And actually, this is great because it happens to be right on one of our little lines here. So if, say, we're in Texas and an earthquake happens in California about 4,000 kilometers away, well, it's going to take, we just said the P wave will get here in 7 minutes, but the S wave is going to take 12 minutes and 40 seconds. So the S wave is going to take 12 minutes and 40 seconds. Now that's pretty wild. And shows you, that they're just slower, and it takes them longer to get here once that earthquake actually happens. So in the, I hope that kind of clears up how to generally use this. It doesn't really, doesn't seem intuitive because the S curve, it like goes higher up and it's way up here in this zone of the graph. But remember what we're looking at here. That's saying that it's taking this many minutes to go that far. But a P wave, let's say, you're way out here, a P wave is only going to take that much time. So an S wave takes that long, a P wave takes that long. So that's what this chart is all about. Now, in the next video, this other guy is going to walk you through an example of how to use this thing. Just so you know, though, this piece of paper that you have is super important to help you actually figure out eventually the difference, using the difference in arrival times between the P and the S wave that you can get from a seismogram, which, again, we're going to go through that whole process. But I'm just going to say, you can use a piece of paper right up against that X or Y axis there, right against the side of the graph. And if you want to say, oh, let's pretend that the S wave arrived 4 minutes later than the P wave, here's what you do. We zoom in and we mark 0, and then we mark 4. And so if this is the other way to use this chart, which is actually the most valuable out of all of them. So now if I actually take if I know for whatever reason by reading a seismogram that the S wave arrived 4 minutes after the P wave, I can now use this thing and actually move this up so that I have the gap. See the gap right there? That's a gap of 4 minutes between my little red marks or ticks. That's going to be right about there. I'm going to try and, you want to keep your paper completely vertical and straight, but that's right about there. So if I know I get a P wave and then 4 minutes later an S wave gets there, that's telling me that gap of time is telling me how far away from the epicenter I am. And how do I figure that out? Well, now that I'm set where I know where that gap fits right between the, and by gap, I mean that thing right there. I know exactly how far from the epicenter I am by tracing straight down right along there. So again, let's say that one more time. If I'm say, let's say I'm in Dallas, Texas, and I have a P wave that gets to me and I feel the earth shaking, and then I get that little delay and then the S wave comes in 4 minutes later, that means that I am exactly 2,600 kilometers away from that epicenter. So that's how we use this chart. It is super neat, and it works pretty much for all earthquakes around the globe. So this preferably for closer earthquakes. This one only gets us out to about 10,000 kilometers, but that's still quite a ways. So that is how you use it, and hopefully that kind of clears up some of the, looks a little more confusing than it is at first glance. But as you go through examples, you'll start to use that process that I just went through over and over and over again. And he's going to talk to you in this next video about how you can actually use, let's say I know now that I'm 2,600 kilometers away. So I'm going to move that whole thing over there. And if I am 2,600 kilometers away, I can actually now figure out, well, how long did it take the P wave to get to me? Well, if I am 2,600 kilometers away, all I have to do is run up until I hit the P wave curve right there. And guess what? That tells me it took exactly 5 minutes for that P wave to come from wherever that earthquake happened and basically arrive here wherever I'm sitting. Same for the S wave. If I'm 2,600 kilometers away, I can continue going up, hit that curve, the S wave curve now, notice PS. Now that's actually kind of convenient. It's right around 9 minutes. So, just another little tool you have in your tool belt to kind of figure out some of the unknown things. So you'll see how the seismograms are connected to the numbers that you need to use in this chart in the next video, but I just wanted you to see how this chart actually works. So that's it for this one.